Alright, this video is the Hutchison effect, and what this does, this guy's been around a long time, and I've been watching his work, and it's spectacular. Now, what he has done, and I think I understand this now, I'm going to try to explain it to the best I can in the atomic realm. Now, he has created frequency generators that literally shake the molecular structure inside of the atomic bonds that hold the little particles in place. They can only stay in these certain regions, and he's shaking them so violently that they're becoming unglued, literally, and he ends up with what you see on the screen here. Now, it's called the Hutchison effect, and I'm doing this in the Fair Use Act, and so I'm not making any money on it, but I'm going to show what happens. Now, I'm going to run this for a second, and I'm going to try to explain what happens here.
Theories are coming up almost weekly on what is
He's saying
here.
theories are coming up weekly.
Physics,
He can lift them.
Lots of power to do this. There's no radio waves or anything that can do this. There's no electrostatic fields or lightning bolts that can do this. So in the way the theory is, key waves made up of electromagnetic and electrostatic fields that I produce, opening a doorway into another dimension that allows any kind of amount of energy to come in and do this, to create these effects.
This appears to be what Rodney Warren has done with light, and I will show you that in a minute.
We've had larger samples, of course.
Now, he's talking about terawatts. That's a lot of juice. Rodney has accelerated light beyond light speed through a venturi, and it may be in that range. I'll show you that in a minute.
For mankind, and also for propulsion and space travel.
This guy is a good guy.
I don't go into mathematics at all. I visualize things and always joust, so to speak.
See this?
He's
He's literally shaking the molecules of the water violently.
Through math.
Now look at this. You can melt.
I put it in the best words that I can.
The same thing. Bonds in.
Actually see the atom.
Look at he's melting it.
See the different interactions of the dimensions inside of an atom.
And this is not unknown. It can be done.
I can explain it in those terms, visualize it, and actually do it physically. But mathematically, I am a basket case when it comes to trying to understand mathematics.
And the mathematics are I mean, I think they could be done. I couldn't do it, but it relates to the amount of frequency needed to shake a particular bond and rip it away and let it fall apart. So anyway, I'm going to show another piece shows the actual melting of metals. Well, you're going to see it here.
Doing it, making the thing in reality instead.
Look, watch. He's exciting this.
There's a little bit of backbiting, but there's a lot around the world, scientists, very high-powered scientists, that were involved in the old Star Wars program, talking a lot of this now. They get into the psychic aspects of it, also the physics aspect of it also. A lot of the work is coming out, released, Lawrence Livermore. Still, Los Alamos is a little
That was a zillion years ago, and it's all,
Alexander now
I don't know, covered up or whatever you want to call it.
He's the head fellow involved in non-lethal weapon technology.
It's the only thing they were interested in.
Ed Gaines is now out of the ISCOM.
Anyway, these melt. The metal melts, so I can show you another shot. All right, here's another one. Now, listen to this sizzle that you hear. Rodney, when he does his light experiments, he's using a venturi and putting a laser through that venturi, and I'll show you what happens, and it gives him a sizzle as well. So it has something to do with what's going on here. Now watch, listen. You hear that? Now watch what happens to this piece of metal. This is a block of steel or something. Inside, the bonds are shaken. They're shaken so hard and so violent that finally it just can't hold itself together anymore. And this is what happens. And the heat inside is obviously because you're shaking it like you're, beating it up. And that's what you end up with. Now, I'm going to show you something else that it just just shows exactly what
Just pull
happened.
it out of the test area over there.
All right, and again, fair use.
Put some paper on in the hallway here.
And this is the guy, Abraham
This used to be
Hoffs Rodriguez. Okay, now I'm going to show you something else. It's just going to show you this. You can't hardly deny it.
Just under 2.
All right. I used to do this a lot, as you can see here. This thing is filled with all these kind of equations and this and that. And now, what I'm going to tell you and show you is that the way, whoops, can you see this? All right. The way a molecule, or, you know, the atomic bonds inside of molecules, which means you got a couple of different centers. The nucleuses, everybody knows what that is, the center, and then you got a bunch of electrons around it. Now, that's the nucleus, you see? And then you have electrons around it, and they bond with other things, you see? Now, you have a literal length of distance that electron has to stay at. They're, you know, the regions in space that are away from this, and they are way away from it. It's amazing. But anyway, they can only occupy such a region. Now, I'm going to show you what happened to a bridge. And you think of this, that if you hit this with a frequency, and we know these will vibrate because quartz crystals, piezoelectric crystals, give off an exact frequency. That's how the clocks run and all that business, and you get sparks and everything. Now, we know that if we vibrate this, we'll create electricity. So, we know that if we vibrate this and we shake, well, I know, this is my suspicion, and I believe it's fact. If we shake this long enough, and that's the key, long enough at the correct vibration, it will start to resonate and it will get this huge, huge wave. And what will happen is it'll literally rip that electron away and let this thing do whatever it wants, and it'll heat up and it'll do all kinds of things and melt it. And I don't, you know, I mean, there's all kinds of things. I don't know what could happen in there, but it's atomic destruction. Now, I mean, it literally is. The damn thing will be shaking like hell, and then all of a sudden, boop, it combusts. It'll fall apart. It'll turn into other metals. I mean, that's just it's going to happen. Now, and the reason why is that? I mean, why wouldn't it just settle back there and be fine? It rips itself apart. You can only go so far. You can only stretch that bond, and when you do, as this thing waves, think of how first of it's this long. And then it's a little longer, and then it's a little longer, and then it gets way out to long, and then it's gone. And that's what, you know, it's really almost like linear, what do you call it, this spin, angular momentum. It's a linear momentum on this case. Anyway, now, so we know that these things are bonded and they're in a certain area. And here, now, I mean, I'm loaded with this stuff. So I'm not just kidding around and playing games here. I know what I'm talking about. Now, and they see stability, they have to be in a certain area to stay stable. Anyway, that's just the way things are. Now, I'm going to show you, hold on a second. Okay, nature is just elegant. Where do you see this? Tacoma Narrows Bridge collapses. Now, listen to this. This is deadly. Hold on. Here we go.
That no man can fail to hear.
No man can fail to hear. Hold on.
In a 40-mile-an-hour gale, the center span weaves like a ribbon in a swinging twist that you wouldn't believe possible unless you could see it as you do now.
Where do you see this guy? I think he wanted to save his car.
There's an automobile caught on the heaving roadway. The 11,000-ton center span twists and strains the giant cables that support it. Cables of 6,300 wire strands, each 17 inches
Now,
thick.
here's the key. It didn't snap like in 10 seconds. This took a few minutes. There it goes, but it just kept getting worse and worse. That's the key to the whole thing. Whoops, hold on. This is a little loud, I'm sure. Alright, so now it's getting worse. It's getting worse. It's pulling itself.
All stricken spectators are driven to safety as the bridge gyrates like a nightmare high above the river.
Alright, this is what Hutchison is doing. At some point, it just can't hold itself together anymore.
The lone motorist is forced to abandon the car.
Look at this guy.
To save himself.
He doesn't know whether to go back and get his car.
His destiny hanging in the balance.
This,
Will he heed the last warning?
this is
or
hilarious.
perish with the doomed structure?
Oh, well, I guess I lost my car. Yeah, I guess so. Hey, what are you going to do?
But he saved himself by seconds.
Can you imagine? Probably had a lot of payments. All right, hold on. Here we go. Anyway, here he goes. He just can't hold it anymore, and that is what Hutchison's accomplished. Nature's just showing you the whole thing right in the front of your face. Open your eyes and you shall see. All right, and the way these, this video is, I do light theory and atomic theory and Rodney Warren, and I do experiments with lasers and prisms, and he came up with the concept of a Venturi slit, and he works in literally other dimensions. Now he doesn't do the atomic stuff, but he's literally works in other dimensions. Now I don't understand that work, and that is not my realm, and he is not in my realm. But his work supports my theory, and he has got closer to another dimension than anybody with string theory or bubble theory or all these kind of theories. He's got actual visual evidence that seems to support what he is indicating. Now, I don't, that's for anybody else to understand, because I'm strictly with physics and energy and that kind of stuff. Now, here's my anyway, that's Rodney Warren, Australia, super guy, hard worker, a lot of, very, very, an experimenter. Anyway, this is called light is dark energy until it hits matter and bounces, and literally that's what it is. Now, I'm going to play this and just listen to. Well, let me just explain it to you instead of playing it. I'm going to expand. Well, maybe I'll come in on it and get a little clearer. Now, you got the sun that has energy. We know that. It's spitting out energy. It's pushing solar sails. We know all that's happening. When it comes, the sunshine comes out of here. They're particles. There's no question about it. Now, but they're dark. They're dark when they're in space because they're in a vacuum. And in that vacuum, they have no nucleated particles. And a nucleated particle means it's got a nucleus with protons and neutrons, and then it has a cloud of electrons, and that's why they bounce off that cloud when the electrons from the sun are emitted. They're spinning like crazy because they're just thrown out of there from the violent vibrations. Everything is vibrations. And that's why the bridge is the vibrations, the metal is the vibrations, the quantum states are the vibrations. They're the hum of life, and that's just it. It's basically case closed. Now, if you can shake those bonds loose, then they're going to go somewhere else. And that's really what acids and so forth do. They literally crack bonds, they call it. Now, it's not the same process. We're using a stretching of the bond, literally, to break it. Now, the chemical changes the pH, and it adds an extra electron, it takes one away, that kind of thing. So it's a chemical process versus, literally banging the hell out of it. But the process has to stay. Well, anyway, let's go back to this. Now, we know when that shoots the particle off, there's energy here, there's no question. When it's in space, there's energy. It can't be anything but energy. And then we know it's a particle because it hit things and move them. So it's an energetic particle, which means it's dark matter and dark energy. You don't see it. We don't measure it. We don't even know it's out there. They don't take it into consideration at all. It is the literal, for me, it's the animating breath of God, literally, because that is the thing that makes every single thing eats that. That's what they eat. This spits out electrons, and there are electrons, no question. We have video. I'm going to show you. Rodney does fabulous work. this vortex, I mean this, well, my vortex theory and his Venturi slit, it locks it up as far as I'm concerned. No. So anyway, it's dark energy, dark matter in space because it's a vacuum, and anything out there has nothing to collide with but each other, and they don't interact with each other very, very lightly. We have actual picture of light interacting with each other in the plates and shooting off a small piece of light, and I'll show you that in a minute. Now, so the vortex particles are electrons all by themselves, nothing else, zipping out through space. The faster they spin, the more angular momentum, the more angular momentum, the more mass. The more mass, the more energy. C squared was not well, C squared actually is a variable. Einstein said it wasn't. It obviously, as we can accelerate it, we can slow it down really almost to a crawl. So that's just silly. Now, it goes through water, it does something. He said light has no mass. Well, that's obviously wrong. We know, I just explained what light does. We know it hits things and moves them and does all that stuff. So that's silly that light has no mass. And even his own equation doesn't work. If it has no mass, it has no energy. We know light has energy. Who would say light doesn't have energy? So if no mass, there's no energy. That's his own equation. So I'm not going with Einstein on a lot of stuff. Now, this is a spinning particle. It's not a duality. There's no spinning this and that and radio waves and all this business. It's a spinning particle that just gets thrown off of the sun, just like a rocket. Zip, it spins. As soon as it collides with our atmosphere, which has nucleated particles, which means they're nucleuses. And it's like a big rubber ball. It hits it and bounces off, or it shakes it and it heats it up as heat. So you get heat and light. That's the nature of these particles. They're vortex particles. Now, I'm going to show you Rodney's work. We both do the light experiments, but he's the one that really, this guy's something. So anyway, I do a little bit of it here, but my size is there. All right, I did another video. Well, this is the same video, I guess. It's light is dark energy until it hits matter and bounces. And these are on Mud Fossils channel. I have mudfossils.com on YouTube, and I just started Mud Fossils University. And there will be very few hits on the Mud Fossils University. I'm not advertising, I'm putting no tags, no nothing. I just want people that are truly interested to go there and look. It's called Mud Fossils University. And that's it, it's free. You'll never get any credit from anybody, they'll laugh at you. Alright, this is a different video, and I would love to have somebody do this because I think this could be a super enhancer for solar collectors. I mean, it's just obvious to me. Now, I have same thing again. This is on my mudfossils.com channel on YouTube. And this is called Solar Collection Efficiency Challenge. Open to all. I don't care about making a penny. I don't want to make a penny on anything I do online. I'm just doing this to just because I'm having fun. Now, remember that shot. Now watch this. Well, here's what I'm thinking. If you take, let's go find the, where are we here? Forget that. That shot right that we went just by is not anything to pay attention to. It's not mine. It was put there by mistake, and I can't validate it. Now, all right, let's go out here and see. All right, here we go. Now, hold on a second. This is not a guy's face. This is our Venturi. Now, I'm going to show you something that could enhance solar collection exponentially, but it's got to be checked. Now, you saw that disc compressing into the Venturi and coming out in those high frequency white sprays, and you also saw a backlash, and if you go back you'll see it, and they flipped out back here. You're losing some of that shot. It's shooting back off of hitting the tops here. Now, think about this: waveguides. You know, this is just waves. It's just exactly, they really literally are like water. Now, the light is coming down. These are the vortex particles. They're coming down, spinning down from wherever they come from. And you know, car headlights do the same thing. They're vortex particles. There's an excitement going on in the atomic level, and it's just too much, and they shoot these electrons out. And we're living in a soup of electrons because they're hitting us like unbelievable amounts. One of my videos talks about how fast the Earth is growing. It's unbelievable if you take into account. We're getting hit by those. They weigh 0.00055 atomic mass units, case closed. That's all. We're not re-radiating that much of those. They grow plants. They make everything grow. We eat the plants, case closed. We're living off of light. Now, so let's go back to this. We got the Venturi coming through. We got atomic white light, very, very high energy. It's coming through in here in drops. It's coming out of here in machine gun bullets. Now, here's what I'm proposing. And anybody can do this. And I love this. And it's just simple. I was thinking of doing it with razor blades. I just don't have time. Take razor blades and make a grill like this. And you point the sharp ends up, break them, and sort of round off the bottom so that they're almost touching each other, and you could put them in foam. So I would put a block of foam at the top. Well, see, these are in the wrong orientation. Let me draw a shot of this and I'll show you. All right, here's going to be the device. All it's got to do is you're going to have two pieces like this because they've got to be squared up well. And then in between them, you're going to put all your razor blades. Now, when the light shines through it, it's going to accelerate through those razor blades. It'll look like this. The two pieces of rubber like I showed you will be here, and then you're going to slide your razor like this piece right here. You're going to break it and maybe grind it so that it's, you know, what's going to happen is, think about what we saw in the video. The light is screwing in here, and it's going to penetrate in between these, and it will accelerate. It has to accelerate. There's nothing you can do because there's not enough room for it to get through here in its entirety without accelerating or exploding, and it does both. Now, you take this, tip it this way. Whoops, you know, you tip it this way and down. Now the light will be coming through. Remember how that disc was literally sucked into that single Venturi. Now we're going to have, let's say, 10 blades. You know, you take 5 blades, you break them in half, and you slide them in between here. Chip, 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 chip. Well, actually, they're going to be this direction, but you see how it's coming through here. So they would be actually be in this direction, and the light is going to be going in between these two spots. Now, when it does, it's got to accelerate, and it's going to come out of here for a certain distance, which we saw is really, you know, I think it's like I'm not sure. It's maybe 1/8 of an inch, 1/2 an inch, but this should be mounted as close to the surface of the solar panel as you can get it. Now, my feeling is, coming out of there, it's going to come out with a very high, literally high voltage. I mean, that's exactly what it is. It's coming in a low voltage, just sort of trickling in sunlight, and then it says, hey, I got to crush and push you guys out of the way, and that is what you're doing, is pushing other electrons, because that's all they are, is light, which is spinning electrons. You know, the particles that are, they're spinning electrons, vortex electrons. So it's pushing through here and accelerating on the other side. So now, instead of a volt, you got 10 volts. You might have 1,000 volts. I have no clue. I want somebody to look this up. And here's the deal. That's the output. So you're going to have to check the output. It's very simple. Somebody do this in a matter of minutes. I'm doing other things. And I don't want any money. I don't care about anything. Rodney Warren, you should kick him, because he's the guy, you know, if this ever went anywhere. But, you know, think about Rodney. He's the guy that actually did this, and if it wasn't for him, I wouldn't have understood what it is, and nothing would ever have happened. Anyway, so he's the guy you want to credit for this kind of Venturi. Anyway, what it could do, like I said, it could up the voltage, but I don't know that. So somebody has to do these things. And I've tried to get a hold of MIT and Stanford and places like that, and they're not interested. So I'm taking it to the streets. Free to all. I don't want anybody trying to scam anybody on this. I came up with this. Rodney came up with this. We just want something good to come out of it, all right? So, you know, if somebody does try to grab onto this and steal it, hopefully humanity won't allow that. And besides, there's no priority here. You could sell these blades and sell the rubber things. The guy can make them in 15 minutes. Anyway, so free for everybody. Please, this is not for greed. That's just my statement. Nothing. There's no restrictions on this. You figure out how to use it, just go ahead and use it. Have a nice day. Sell it, do whatever you can. Get as little money for it as you can. It would be my recommendation, because you're going to be up against everybody else in the world. That's how it should be. Nobody gets to say, ooh, this is mine. All right? Everybody understand that? That's it. Case closed.